Okay, do you understand if from next week we don't have a class on Friday? Your lecture will be on Tuesday in class room 240. Okay? The reason we stop Zoom in your schedule, the thing I want to working with individual with each student in schedule, not too many. You understand the schedule cannot be more students like Tech 1. The reason they only be Tech 2 if they pass through the Tech 1. So that's why Tech 2 is not much student. Okay? I will be open the room 240 on Tuesday at 4 o'clock. What I tell you, I want to working with individual, each student, to make sure you know what to do, how to do in the digital lab. Tech 2 more easier than Tech 1. Only you have to deal with the digital lab. I want to teach you the real thing. That means whatever you get a job in a company doing technician job, you can say they the same as we're talking to you. That's a real. Okay? So I make sure guarantee the student in Tech 2 able to get the complete certification for each student. I have to know you know how to do or not. Otherwise, you can stay in Tech 2 forever. So any question or anything you don't know, you can talk to me in the class. Bring it up. I try to help you. If I try it and you still cannot get through it, that takes very long time to stay in Tech 2. Okay, so that is the general what we are going to do. We can go back to the Zoom until I feel all of the students in Tech 2 know what to do, how to do. Okay? For now, I'm not taught anyone. Even few students, they in the program too long. And now they can working up to the lab 12, 13, or 14. Okay? But I still not really trust or not the student know what to do. That's the thing is, we get the COVID-19, so almost over 3 years, we not do anything. We just started about maybe from last summer. Okay? So before we start for the program, I want to know to get any question, any confusing, anything. Just bring it up. Okay, nothing. Okay. So today I will be start over. Okay. The thing in last meeting I recorded, but for some reason that record be erased. So that's why I cannot put on the web. Today I believe will be okay. Okay, just a minute. I want to get in general first. Okay, first thing I will be talking about the lab number 2. The way to do the same like the lab number 1. Okay, first thing when you're looking into the schematic, I get a question to that circuitry, how many input? Okay, if you want me to teach you, you have to answer me, okay?
5 inputs?
How many input for that circuit?
5.
Okay, correct. PA 1, 2, 3, 4. PB 1, 2, 3. How many output?
3.
3. Correct. PC 1, 3, 5. How many IC for this circuit? IC means integrated circuitry. We already get through that. You know the AND gate, NAND gate, NOT gate, exclusive OR. That is just one IC. So how many IC?
4.
4. Okay. You say, in order to know how many IC, just looking for U. That means unit, U1, 1 IC, U2, second, U3, and the last one, U4, 4 unit. That's the same in the company. One circuitry, they get 20 IC. The first one will be U1, U2, U3, up to U20. Okay? So, this circuitry get 4 IC. The first one, 7400, NAND gate, 7408, AND gate, 7486, exclusive OR. Okay? And 7402, NOR gate. Okay? So they get 4 IC. How many gate in this circuit? How many gate?
6.
All right. You can count. 1, 2, 3, 4, 5, 6. 6 gate. Okay. When you're looking into the circuitry schematic, any confusing, anything else, I can answer to you. Okay, if it's not, now I'm talking about when you do build your lab, okay? The way have to be this way. The first one, U1. Then the next one, U2. The next one, U3. And that will be U4. They must be followed that way. We don't care what the part number. 74000886 or 02. But they must be followed the order. Unit 1, U1, U2, U3, U4. Okay? And this pin will be pin number 1. And this one, 7. This one here. And that will be 14. That is the way. And the IC, depending on how many pins. 14, 16, 18, 20. They have to be go that way. Okay? When you see the dot in here, you know that pin number 1. 1, then 2, 3, 4, 6, 7, 8, 14. The reason you have to go by that order. For example, I want you to measure U3 pin 6. Okay? Then you can go into your circuit board. You know that 1, 2, 3. This is the one I want to measure. Okay? And pin 6 will be here. We don't have to looking for the part number. 74000886 or 02. Anyone not go by this order, you have to redo it. Okay, so any question about layout your IC when you build a lab? Okay, look like you're like, okay, right? Now, we're talking about build the circuit. The way to do, first thing you want, you understand the 14, pin 14 will be 5 volt. Pin 7 will be round. For on off, that I see. So when you build, first thing you connect that one, 5 volt. That one, 5 volt. That's the first thing you have to connect. The second thing, 7 will be drowned. Okay? The IC cannot working without 5 volt and ground. Digital circuitry only need 5 volt and 0 volt, that means ground. So not dangerous to your guys, okay? Don't worry about that. This is the first thing. I show you the way you can build. Connect 5 volt for HIC. Then connect ground. Okay? And after you're done, now, you're looking at the schematic. First thing you connect for U1 first. U1. Pin 1 to connect to the setup level alone. Pin 3 connect to 4. U, basically, that will be U2. U3 pin U3. Okay? Not 32. That typo problem. So, you connect the wire from U1 pin 3 to U3 pin 4. Okay? So, that will be done for U1A. U1. Now we'll go to U2. U2 pin 2. Connect U3 pin 1. U3 pin 3. Connect to U3 pin 5. Connect to U4 pin 2. Okay? Then, U2 anymore. No. U3. U3 pin 1. Connect here. U3 pin 3. Connect U4 pin 3. Connect U4 pin 5. Connect U4 pin 6. Normally in the past, we're using the marker, yellow one. Just make sure you get yellow after you're done. That means you're looking into the schematic, guarantee on the wire already connected. Okay? And also, make sure one thing. On the wire cannot go across the IC. Okay? I won't leave the IC alone. Okay? That means if you want to measure the U1 pin number 5, then you can using the meter connect to U1 pin number 5. If you got too many wire around, like too many wire around it, I see. So when you try to access into pin number 5, cannot. That's why you cannot do that way. Next week, on Tuesday, in the class, I will be given to you the sample. You're looking into that in order to build your circuit. The thing is, most of students don't understand. That means they try to using the meter to take the wire, continue it, to make sure the wire go right place. But that is not supposed to be. Okay? Only thing you take the wire if when the test failed. Okay? So you can develop your software to test the circuit. Okay, the processing after you build your circuitry completely, you get your software ready to test, and you have to run. If on the test part, that means you're doing good on that lab. If the test fails, when it fails, you get two problems. First thing, the problem with your program is not right. The second thing, problem, maybe you connect the wiring not correct, or you're not lucky, the IC in the circuitry really not working. You see that? We can solve only equation with a one unknown when you get a two unknown. That means you cannot do it. So I will be the one support the maximum your software. When you run it fail, then I have to make sure guarantee your software is good. Okay? If your software is good, you run it fast, that you okay. However, if it fails, that means your circuit you build, you get a problem. That's what I want to teach you. Okay? For example, for this circuitry here, first thing, I short it to round. What I try to do, when I short L3 pin 6 to round, what they telling you, the purpose, what I want to do. When you run the test will be failed. But you know the purpose. What I try to do. Okay.
Testing to see which component is wrong.
Exactly. I short L3 pin 6 to round. That means I telling you L3 pin L3 not working. Correct?
Yes.
The thing is that pin cannot go to 1. Okay? So you run the test, they will be failed. When they say in the program L3 pin 6 at logic 1, and that have to be failed, the thing is they cannot be 1. So when you run it fail, what you are doing, that's what I want to teach you. Problem solving. Okay? So now you see, you can get input 0, 0, that's 1. That means this is the 1 here, and this 0 here. That means on analyze the circuitry, in order to get a 1 here, then you get 1 here, 0 here. Okay? So, when it fails, what I want you to do using DMM, positive and negative. Negative connect to ground. Okay? Positive connect to L3 pin 6. Okay? Now, if you make the L3 pin 6, what logic you get?
Can you repeat that?
What logic you get at U3 pin 6? Look like you get 0 volt, right?
Yes.
Okay, now you can get a 0 volt. You can get a 1 volt. You can get a 3 volt. Okay? I suppose you get 0. But really you want it to be a what? Have to be 3 volt or more. So that's why it's wrong. Telling me, next step, what you think you do?
Well, work backwards from 6 to
Okay. Now you know it's wrong at pin 6, right?
yeah.
Okay. Tell me what next step you
Uh
want to do.
check pin 4 and 5 for
Perfect. Now, you have to using the meter. Measure U3 pin 4. Correct?
yes.
What you want?
A 1.
1. That means you get 3 volt.
Mhm.
4 volt. 3.5. That's okay. Good. Then what next?
You want to get a 0 at pin 5.
Okay, then you measure U3 pin 5. You're supposed to get 0 volt. 0, 0.1, 0.2, 0.3, 0.4, whatever. Okay, good. What next? What next step you want to do? Okay, you don't know.
Mhm.
At that point, you have to talk to me. To say, I want to change U3. That means you need a new U3.
Oh,
Okay? And I can ask you, why you say U3 not good? Then you can say, okay, output pin 6 supposed to be a 1. But they not. I measure pin 4, they at logic 1. Measure pin 5 at logic 0. Input is correct, but the output is not. That's why I say that IC not working. You see that? That's what they call troubleshooting. And I don't want anyone, when it fails, you using the meter to measure continuity. Just make sure the wire going the right one. No, that is not technician job. You understand in the company, the wire in the middle of the layer. That means you cannot see any wire, cannot be broken. Okay? Only thing is you have to prove the part is not working, but they get a wrong output, but they get the right input, then you change that IC. That's what you learn for troubleshooting. This is a simple program. However, later The board will be more IC. Okay. More wire. So will be more problems. However, if you know how to solve the problem, that is a key point. Okay. By the way, I want to ask you another thing. When you measure U3 pin 4, you get logic 1, you say okay. When you measure U3 pin 5, you get 1.5 volt. You want a 0. 1.5 volt. It's not 0. It's not 1. So you know wrong. U3 pin 5. What next step?
You have to check U2 pin 3.
Perfect. You know how to do. So that's why you have to go to take in here. Okay. At that point, U2 pin 3. What you want?
Ground?
0. Right?
Oh yeah.
Now, if you get a 0 here, what can you do? If you get a 0 U2 pin 3, however, U3 pin 5, you get 1.5 volt. Tell me, what can you do?
Do you repeat the same process
What was
ground at U2 pin 3 to check for
you check? You already checked U2 pin 3 at 0, right?
oh okay. So would what it has to do with the wire?
Exactly. I'm talking about the lab in this program, not in the company. In the company, we do not deal with the wiring. The wiring cannot be broken. Okay. So now you can see you get a wire. Okay. From here, go here, go here. How come this is 0, this is 1.5? So the wire have to be a problem. So that's why now you can using the continuing using DMM. Connect 1 to pin 5, 1 to pin 3. Make sure they bring it out. That means good connection. However, make sure pin 5, okay, cannot go anywhere else at the wrong place. That means you try to fix the wire. That is the whole thing for troubleshooting. You get the wrong output, you have to see input if they right. IC not working. If the input is not right, keep going. Okay, to the back. To find out what's wrong, where wrong. Okay, any question? Anything?
No.
Okay, if it's not, now I will be run the DLAB number 2. Show you something before I start. So how can we help you? You do your left. Okay. Okay, let's see. Okay, so if I want to run the program, DLAB date will be DLAB 2. Okay, now you can go debug, start without debugging. They will get a total 18 tests. Okay, so you know the test is passed. That's what I want you to run when you done your circuitry and your software. If you get the part, okay, that's telling me you get the job done. Now, I shorted you 3 pin 6 to round. Okay, I want to explain a little more for you. What happened when they fail? Okay, run again. Okay, so now that's what I try to make sure when you read it, you understand what's going on. First thing is, okay, fail test number 1. Test title, test 01. Expect data. What that mean? That means the data you want Okay, and measure data. That means the data computer reading, telling you. If you're looking on that one and you see they will be failed at pin output pin number 1. You want 1, but the computer read 0. We're not talking about Pico at this time. That is more confusing. However, when you're looking the message display, you know what you want and what the computer reading from your circuitry. Okay? Okay, any question? Anything? Okay, if it's not, now I'm telling you, how can we do the lab? Okay, so when you get this circuitry, I don't want to analyze circuitry. That means you enter what input, what is the output, what input, what output, input, input, you get what output. That takes a long time. Okay, so that's why normally simple circuitry, we're using PSPI to run the simulation. PSPI simulation, they're asking you enter your input of the circuitry, and they given to you the output. Okay, now we're going down here. This is your input, okay, of the circuit. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 for pin number PA1, PA2.
Mr. Fan, we can't see the circuit.
What?
We can't see the circuit.
You can see the circuitry. I already said it.
We're not able to see the screen that you're looking at currently at the moment.
Okay, let's see. I want to make sure you can see the circuit. Okay. Now you see the circuitry or not?
Still no.
You didn't see circuit here? Timing?
It's still on the regular desktop screen, sir.
Let's see. I already stopped that guy. Can you see it now?
Not yet, sir.
Uh-oh. Okay, just a minute. Okay. Okay, I try share again.
We see it now, sir. Thank you.
Okay, okay. That's good. Okay. Now we're using a P-SPICE. Then you have to given the input of the circuitry, and they given to you the output. And on this here, we already given you the input, PA, pin 0, 1. 0, then 1, 0, then 1, 0, then 1. Keep going. Okay, PA number 2. At the beginning, they will be 1. 1 for how long? 1, 2, 3. See that?
Yes.
Then they go low for
0.
1 microsecond.
Oh, yeah.
Then they go back high. For how long?
2 microseconds.
Yeah, and so on. And pin number BB1. They will be 0 for 1, 2 microsecond. And low and high for 1, 2. Okay? Then they will be low for 1, 2, 3, 4, and so on. That's what you have to tell the P-SPICE. Okay? So in order to get input here, that's what you will be. Edit the file. We call it include. Okay? Now, I start with the P-SPICE. Okay, so now you see the P-SPICE. Okay, I can open the file LAB2. You see the schematic, right?
Yes.
Do you see that?
Yes, we see it.
Okay. So, how can we get 7400? Okay, I try another one, new here. Okay. First thing you have to get 7400. So you go to draw. Get a new part. You click on 7400 here. Okay. Play. That's the one. Just leave it there. The next one, 7408. You go to 08. Play. Here, you. And the next one, 7486. here. Next one. And the last one, 7402. Okay. Then now you need to get you want that one here, connector. Okay. So that telling you go to get, I think, global. Let's see. DL global here. Global. Okay. And you take that out. Put up here. Anything else that we need. Okay. Now you will be need to include. That here, include. Okay. So go into I, include here. Okay. Then now you click here. And you close. Okay, that basically you get almost what you want. Okay, so now you have to arrange. I see you want 7400. Try to make it bigger. Okay, first thing I put U1A here, go here. Second thing, that U1. Okay, now you get U2. Okay, U2 7408 here. Okay, you can move it here. Take U2 here. 7408 here. Okay. What next? U3. U3 here. Okay. Make sure they turn red, then you can move. Okay. That will be U3. Okay, U3. Now we get another U3. So you get U3 ready. Okay, turn it red. Control C, copy. Control V, paste them out. Okay, so that's why you can get another U3. Okay, put U3 back here. And now that one, they say U5, you have to change to U3. Okay, change it to U3. Now, this is an inclusive OR. Inside 7486, how many gate you get? If you're looking into the handout, at the beginning, you can see they get a 4 gate. And this gate is number A. And basically the next one, you want it to be B. So when you change it to B, automatically they change the pin number. Okay? And then you get a U4. Okay? That will be U4. Okay, U4. You get the next one, U4. Okay? So you get U4 ready. Turn red, Control C, copy, Control V. Okay? And this new one, they say U6. However, they're supposed to be U4. Change it to U4. And the park we already get, they park A. Get A. Now they will be get B. Okay, they change the pin number. Okay. Any question how to draw that basically? Okay.
No.
If it's not, now we're talking about connector here. Make sure they red, you can move. That's the one. You want another one. Control copy, Control C, Control V. Two. Okay. And PB 1, 2, 3. 1. 2. Let's see. Oh, you still get EGA here. Right here. Okay. So we get another one here. Okay. Okay, so that go here. Okay, so now you can connect the wire. First thing you go draw Y. Okay. One here. One here. Okay. So that one here. You see the dot here. You don't want it, you can delete it and redraw it. But they still working, no problem. See, for any region. I don't care. They're still working. Okay, now you draw for U1 pin 3. L1 pin 3 go to L3 pin 4. Okay. And L2 pin 3 go to L3 pin 5. And also they go to L4 pin 2. Okay. L3 pin 3 go to L4 pin 3. And go to L4 pin 5 and 6. Okay. And then okay, PC1, PC3, PC5. So you can copy one of that one. Turn it red, copy, Control C. Okay, Control V. That is the one. Now, you want it to go backward. Then make sure the red, Control R. Rotate. Okay, you can connect here. And you want it, Control C, Control V. Second one. Okay, so that's almost everything. Almost done. Now you have to assign PA 01. Double click. Okay, typing in PA dot 01. Next one. PA dot 02. Okay, then you get PB123. That one. PB dot 01. Okay. PB dot 02. PB dot 03. Okay. And now you go into output PC1, P3, P5. Okay. That one. PC dot 01. That one. PC dot 03. PC dot 03. 5. Okay, so basically that completely drawing the circuitry. So you get any question how to draw the circuit in PSPI? No questions? Okay, so now I'm talking about include here. Okay, first thing, double click, include. Okay, then click select file name. Okay, you typing in C drive column slot ATT slot. Okay, the name you can say DLAB 02. Okay, dot at the end. Okay, that's what you need to typing in, telling you this include file will be in C drive under directory ETT. Extension will be STM. STM means stimulus. Okay, you say, okay. You see that? Now will be. See, you get a bar over. ETT means directory ETT. DLAB 02 dot STM. What you need to do is edit this file. Double click on that. Okay. When you double click, they given you the notepad. Okay. And you will be typing in. Okay. However, normally you don't have to typing in. You try to copy the one already there. Okay. Let's see. I try to find out. So basically, I can open any file in the ETT computer for the notepad. Okay, I just copy it. Control C, copy. Okay. Now I go to my iPad here. Control V, spit them out. I using this format to change what we need to do. Okay. Now I show you how do we do. First thing, U81. That means the first input, this line cannot change anything. You will be change the name here. The name on your PA.01. So you type in PA that 0, 1. Okay, see how they work. They get a 1, 0, 1 micro, 1, 1 micro, and they keep doing the same thing at the beginning. 0 at 0. Okay. 1 microsecond, they go to 1. And now they keep repeating the same. You using the repeat forever. That means you repeat it 0 then 1. And after that, you have to be and repeat. Okay? This is a formula. You must be follow exactly. Only can for the time. Now, UH2. That means the second one. You say PA02. So now you change that PA02. How they work? At the beginning, they add logic 1. So 0 is second at the beginning. They will be 1. Okay. They 1 for how long? 1, 2, 3, then they go low. Okay. So you can say 3 and they go low. Okay. 3, they go in low. Then they go in high for 2. So 2, they go to 1. Okay. 2, they go to 1. Okay. And they will be, let's see, low 2 go to 1. Then they will be, they go to low. 1, 2, 3, 4. Okay. Okay. And that means you have to keep doing the last one. Okay. 0. Then they go to 1. Okay. Let's see. At the beginning, they 1. They 1 for 3. Then they go low. And they low and 3. 1 is second. No. 1 is second. No. Let's see. 0, they 1. 3 yield. They go low. And 1 yield. They go high. And 2 yield. They go low. And 1, 2, 3, 4. 4 yield. For yield. Go to 1. Okay. 1, 2, 3, 4. And then they go to 1. No more. Okay. And then you will be go into the next one. BB01. Okay, and you can add it for PB01. Okay, keep going. PB02 and PB03. Okay, so now I try to get the one we already done. So we don't want to waste the time on that. Okay, I try to copy the one we already done. Copy. Okay, paste them here. Okay, so we get everything. US4, US5. Okay. PB2, PB1, PB3. PB3, let's see. At the beginning, 0. PB3. At the beginning, they will be 0. How long? 1, 2, 3. 3 years, they go to 1. Okay. Then 3 years, they go to 1. And they will be 1 for 1, 2, 3. Okay. 3 years, they go to 0. 3 years, they go to 0. And they will be 1, 2, 3, 4, 5, 6 years. Okay. Six years, they go to 1. One, two, three. 3 years, they go 0. And 1, 2, 3, they go to 1. Okay, now, the important thing is, after you're done, you go to File. You must be Save. Okay? Don't use Say As. The thing is, this is a file inside the project. So you say, if you say As, you get a problem. So you can click on Say. Edit. Okay? And now, what you need to do, you need to run simulation. You go to Analysis, set it up, select the transient. Only thing you need to change will be final time. Okay, basically, you get a 1810. Okay, now, if you're looking on here, you can see how many microseconds you need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you can set in here, okay? Analysis set up. You want transient, and you can say 20 yield. That's good enough. 20 yield at microsecond. And you say okay. And now you close. Okay? And now you can run simulation. Your analysis simulate. Okay, they want to say. I say that first.
Mr. Pham, you forgot one of the inputs.
What, just a minute.
The input on U3 pin 1 is not connected.
Oh, okay. They connect to YouTube pin 2, right?
That's correct.
The thing otherwise when you run, you get a problem. Thank you. Okay. Now go simulate. Okay. So this is display the simulation. Click on that one. The trade. Add trade. You see too many pins. You don't want too many. So you remove that. Remove that. The thing is you want only digital. So they display PA 1, 2, PB 1, 2, 3. That's the input. And now you want the output. PC 1, 3, 5. You say okay. You see that? They will be displayed the signal. The relation between input output. You want to collect it? Click on that. Okay, toggle cursor. Click on that. Now you click on test number 1. You see the output will be 1, 0, 0. That's what you need to collect. Okay? You go to test number 2. That means here, anywhere in here. The output now will be 0, 0, 0, and so on. Okay? That means this timing here working okay. Then you can get the output you want. Okay? So that's why in here, they just want to know what output for that 1, 2, 3, 4, 5. You enter it. If they say path, that means you're doing wrong. Right here, it's right. Okay? You get that? Now, after you get the output here, okay? You're looking in it, status here. If they pass, that means you're okay. Now, that means for this phase, you need the data here. Okay? Then you go to the quiz. Easy one. They can ask you how many IC. So normally you can say 4, right? 4 IC. How many gate? 6, I think. 6. What pin connect 5 volt? Pin 14. Ground will be pin 7. Part number gate U to A. U to A. 7408. How many pin of the circuitry? 5. How many pin out? 3. Okay, so you done on that. And now the next will be port A. You have to fill in port A, port B, port C. Go in here. Let's see, port A. PA, that number 1, 0, 1. Okay. Let's see. PA 0. That means you get 0 in pin 1. Okay. And that number 2. However, you have to change to the height. So you can say 0, 8, 0, 2. Okay. And now, if you go to B, C, D, E, B here, 0, 1, 0. So you get 0, 1, 0. Change that to height, 0, 8, 1, 0, 2. Okay. Then you go to port C. Let's see what in port C. Output right here, whatever here. Okay. Then you can enter. I don't know what is it. For example, if you get a 1, 0, 0. That's an example. Okay. Then you go to C. Okay. They will be 1, 0. Okay, that's the wrong one. Here, 0. And that will be 0. Change to the height. What is 0? Height what? 0 will be 0. 0, 1. Now, I give you an example. If you get a 1 here, 1 here, 1 here, what number? Tell me. In height,
It would be 1x.
one what? Huh. 0, 8. This is a 1, right? Get a 1. 1, 0, 1.
5.
Perfect. 1, 5. That means you have to change to the height.
Oh, okay.
Okay? Now, I'm talking about map data. Here, what that means. Okay, on the port C, they get 8 bit. Okay? 1 to number 8. When you tell the computer to read the data, they have to read 8 pin data, not only the one you're using. Okay? So in order to do, you have to tell the computer, for 8 pin, I only want this pin only. So that means the pin you're using, you put a 1. 1. 1. And the pin not using will be 0. That means that after the computer read, they get the data to end with the pin you're not using and with 0 anyway, they be 0. And with 1, that means 1 they get 1, 0 they get 0. So now converting to hash data will be 0. What data here?
1,
Is it 1
5.
pi? Okay?
Yeah.
Okay. After you're done, if they say path, okay, path, and they give path, and you're looking into here, they say path, that means you're done. Now, only thing, when you edit your program, you need only port A, port B, port C. Something else we don't care now. Okay? The last thing I'm talking about the program. Okay? So in order to develop your software, I show you here. First thing, you click on Visual C++. Okay, now you say select new project. Okay, so change the name here. You can say DLAB 02, for example, for 2023, that be fine. Okay, and now where you want your program, okay, to be, then you can browse it here. You can say anywhere you want, okay? That's what you can select any folder, anything, okay? Then you can say, okay, the next, you click on next. Okay, take that out. Take that out. Connect empty project and click finish. Okay, now you right click on the project DLAB 2. Right click, you say add new item. Okay, you typing the same name, okay? DLAB 02 and phone, okay? For 2023, for example, and you say add. Okay, now this is ready for you to add your product. What I can telling you, you go into my Excel, okay? Software help, okay? Copy
Okay. What?
that one, copy, Control C. And now you go in here, Control V, okay? Paste them out. Now, I try to explain to you. In here, that means project name, file name, okay? Program name, change to your name. Don't leave my name, okay? Version date, any date, okay? In here, you get that you include file here. If you want to use, you run the test in the class, you using that one. If you want to run program in your computer at home, then you will be using cettio.h. Either one. Then you go to the man here. Okay. Change your name. Okay. See that? Change your name. Okay. Change the version date. Let's say version date here. You can change to, for example, October. Zero 05, 06. Okay. That means ready. I given test to test number 1. Okay. After you get test number 1, I given you test number 2. Now, test number 3, you have to add it. 3, 4, 5, 6, whatever, depending on your here. You see that? Test number 1, what data? 2, what data? 3, what data? And you can enter here. Okay. So, test title. That one. Expect data from port C. Map data from port C. PCOP, we're not talking about PCOP right now. E1, E2, E3, E4, port C. So you have to write port A, what data? Write port B, what data? Okay. Then this is just a copy, cannot be changed anything. Basically, that's what you tell the computer. Go to read the data, then compare to what you want. If it's the same, they bring pass, otherwise they bring it fail. Okay, now you can see the difference. Test number 2. Test title number 2. You didn't see map data. Map data test 1 here. However, test number 2, you not see it. Why? Who can telling me how
You only need it once.
number two test we don't need math data? Okay, I telling you. If that not changing for that two, you don't have to repeat it. That means math data here, they will be valid on of the program. So you don't have to typing again. Next one, P copy here, same thing. Right now we're using U1, U2, U3, U4. That's using for the whole program. So next one, you don't have to repeat it in here. Remember, if you're not changing, you don't have to typing in again. Okay? So after you're done, you go to the build the solution. That means you have to compile. Okay? And you compile, they can say one success, zero fail. That means your program ready to run. Now you want to run. Go debug. Start with down debug. Okay, I see. What error in here? Oh, okay. I know. One thing. I forget to tell you. Okay, on the last one. Okay, after you add new item, you're done. You need to right click on the project again. Right click on that, go to property. Okay, select common language. Click the arrow going down. Select common language /CLR. Apply. Okay, that is why they give you an error. Now you can go, you can run. What error again? 3 error.
Don't you have to rebuild it?
Oh, no. That's when you run the review. But I'm telling you what's wrong in here. For some reason, we're typing error here.
You accidentally deleted the commas
Okay.
earlier.
That is why. That you same thing, right? Missing some I column. Now, you can build, however, if you say you want run stuck without debugging, automatically they build before they run. Okay, so then okay. Why fail? The thing is we don't have a hardware. Okay, so no problem. Only thing is when you run, they run for you. So that is completely doing the lab, digital lab at the beginning. So, you get any question, anything else? If it's not, make sure if you get a problem, you can go to the video I upload tonight, okay? And try to exercise. Do until no problem. Otherwise, you still get a problem with the software or with the simulation. You cannot get the job done. And we will see you guys on Tuesday coming. Okay? Good night and have a good weekend for everyone.
Oh, Mr. Fram, is there gonna be class on Monday?
Just a minute. What? Could you repeat your question? Tell me.
Is there gonna be class on Monday? Can we go into the classroom?
Then what?
Can we go into the classroom on Monday?
Yeah, everyone. Still on Monday.
Okay.
Monday, Tuesday, Wednesday. We'll be in class, right?
Yeah. I think
However, I
Monday's
will be there on Tuesday. To giving the lecture for you guys.
Oh, okay. I was just asking because I think Monday is a holiday or something.
Is it holiday?
I think
October, right?
yes.
No. Monday mean number on the 9th, right?
Yes.
No holiday.
Oh, okay. Thank you.
You're welcome. Okay, so good night, everyone.